So this is the first problem of today's Div 2 Codeforces contest, and in this problem we're given that Milika has a string S of length n consisting only of characters A and B, and she wants to modify S so it contains exactly k instances of B. Now in one operation she can do the following: select an integer I between 1 and n and a character C. C is either like A or B. Now then she'll replace each of the first I characters of string S, that is characters S1 to Si with C. Now we have to find what is the minimum number of operations such that there are exactly k instances of B in string S. So if we look at k is between 0 and n. So first of all, is the answer always possible? See, if we have to make k is between 0 and n, right? Let me look at the problem. So k is between, okay, we have equals to sign here. So k is between 0 and n. See, if k is 0, I can always select this as my index and c is equals to a. Then every character from first index to last index will be a only. So how many occurrences of b will there will be? 0, right? So for this, it's always possible. For n, also I will select this and now my c will be b. So I can also make every character b. What about the remaining characters? For k, any value of k, and also the string can be anything. Like I can have a here, a b here, a, b, b, a, b, let's say a. So for any, let's suppose this is the string, can I have any value of k, like any number of b's in this? The answer is yes. See, we have already looked at 0 and n. For any value in between, what we can do, see, up till this index, if let's say I want 5 or let's say 7 occurrences of b. If I want 7 occurrences of b, I can select maybe these 6 occurrences, these 6 positions, and I'm already getting a b here. So if I convert all these indices, like all these characters present in this part to b, I'll have 6 b's in this plus 1 b, that will be 7. And you can always make any number of b's in your string with these operations. So first of all, the answer is always possible. Is this thing making sense?
Yes, clear.
Okay. But now the thing is, what is the minimum number of operation? See, if the number of b's is already equals to the number of count of b's is already equals to k, then the number of operations will be 0, right? But
Right.
if this is not true, like I have just now said, if you want to increase the number of b's, you start from this place and you just find the index up till which, let's say this is the index I, if I plus remaining number of b's in this, remaining number of b's is equals to k, then this is your answer. Like this is your index and your character c is b. If the count is less than b, then there always exists a child. Is there any doubt in this? If the count of b's in original string is less than k, then I can always find an I such that if I can have these many b's plus the remaining number of b's in this part, I'll add all these b's, I'll get k. Why? Why is this true? See, it is true because remaining b, if count of b's in original string is less than k, remaining b's is also less than k, right?
Right.
So I is always a valid number. I is more than equals to k minus rem of b, remaining b. So if this is positive or this is like positive or 0, this I is always a positive number. And I, like, what is the upper bound? I will be less than n. Why I will be less than n? Because k is maximum n. K is maximum n. Like what is the maximum value that I can take? I can go only up till n, right? So I is a valid number. You'll always get a valid number here. It is a number between 0 or between 1 and n. If count of b is less than k. Is it making sense? Yes, no. Like you'll have to try imagining this. I always exists. You just have to find an I for which I, like this I is one index. I plus remaining number of b's in your right part is equals to k. And if count of b's in original string is less than k, such I always exists. Is it making sense?
Yes, yes, yes.
Okay, like let me take an example. I'll take an example also. But first of all, if count of b is less than k, we have already looked at this case. If count of b is more than k, then this is counterintuitive. You just find a, like you just find an index I for which the number of b's up till I, if you subtract those from already existing count of b's, you'll get k. So that is also the same. Like you can look that to that in a way like you're trying to increase number of a's. So that can be also looked in this manner only. So first of all, let's take an example. Let's take this example only. So yes. So let's say for this the answer will be straightforward 0 because we have two b's and we want two b's. Now we want three b's but we have two b's. So see A, B, A, B. So if we are at this index, this is the first position, first index. So 1 plus we already have two b's in this part. So 1 plus 2 is equals to 3. So this is our index, this is our position and our character C is B. Looking at this, we need 0 b's and we have 5 b's. So we'll go up till last position. Our I will be this and our character will be A. So all these characters will become A and we'll have 0 occurrences of B. Then the next one is this thing and this thing. In this, we'll choose the first index and our character will be A. In this, we want 3 b's and we have more b's. So let's look at this. So we want 3 b's, right? So if we come up till here and we have I as this and we have the strict character A, all of these will become A and we'll be left with 3 b's. Is it clear?
Yes, it's clear.
Okay, so let me show you the implementation. So this is the implementation in this. I've first taken n, k, and s as input. Then if the count of b's in string s is already k, we can print 0 and we can continue. Otherwise, we'll count how many times b appears in string s. Now we're starting from 0 index and a will give us the count of how many times a has occurred and b will give us the number of times b has occurred. Now if k minus x is equals to a, what does this mean? Like the number of times uh, till now a has appeared and I want finally k, right? And if x is the number of b's I already have in my string and k is what I want. So if I subtract this, this simply means this is the further number of a's that further number of b's that I want. This thing. This is basically the number of b's that I want further in my string. So if this is already equals to a, and what does this say? This is the number of a's that have appeared in the prefix up till now. So I can simply do this thing. I, like this is one answer, like the number of minimum operations is one. This is the position I plus one and the character is B. Otherwise, if x minus k is B, this simply means that if k is the number of b's that I want, x is the number of b's that I have. So this is basically I want to remove these many b's. So if this is equals to b, this b is the number of b's that have already occurred in the prefix. If this is equal to this, then this is the minimum number of operation. This is the position and this is the character. I replace all the prefix characters with a. So I hope this is clear, right?
Yes, it's actually clear.
Clear.
So let's go to the next problem. So now in this problem, we are given that Millennia has received an array of integers a1 to an of length n from a secret admirer, and she thinks that making it non-decreasing should help her identify the secret admirer. Now she can use the following operations to make this array non-decreasing. Select an integer ai and break this ai into x and ai minus x. Like if you had a1 to ak, so you'll you you can break ai into x and ai minus x. X can be anything between 1 and ai, not equals to ai. So we have to find the minimum number of operations required for millennia to make the array a non-decreasing. So let me explain the problem here. See, we have, let's suppose these are the values. Like I'm just, instead of writing the value, I have drawn kind of a bar graph. So let's say this is 4, this is 6, this is 3, this is 4, and this is 2. So in order to make it non-decreasing, what I can do, see, this problem can be solved in many ways, but the easiest way is like the way I felt it this problem easy, like it will be easy to solve this problem is to start traversing from end. See, there is no point in breaking this. Why? Because if I break this, if I make this 1 and 1, the number of times that I'll have to break the elements in the prefix now increases. Like it cannot decrease if I break this. Why? Because now I have to make sure that these elements are less than or equals to 1. So I'll try to keep my elements on the right as big as possible so that I don't have to break these elements. So I'll keep this 2. Now this is 4. So now I have to break it. Why? Because I already have a 2, right? So right now we are not actually solving this problem. Right now we are just trying to approach this, like what should be our mindset. So we have a 4, and in like in right we have a 2. So we have to break this. Now what should be the optimal breakage? 1 3, 3 1, 2 2. What do you think out of these?
Make both equal.
Yes, first of all, this is not valid. Why? Because why this is not valid? Because we need the array to be non-decreasing. These two are valid. Now you might think why this is not a better option, but like I have just told you that we'll try to keep our elements as big as possible in the right, so that in the left we don't have to break the elements as many times as we would have broken them if the value was lesser. See, if it is 1, all these elements will need to be 1 only. So we'll have to break it many times. But if the value is 2, I don't need to break this many times. So that's why I'll keep it as 2. So the array becomes, now the value is 3. Now I don't have any choice, but I'll have to break it as 1 and 2 only. I don't have any choice, right? So after this, the elements will be 1 only. Like 1 times 6 and then 1 times 4. So now you got the idea, right? Why this is optimal and why this is sufficient. Yes, no. Or is there any doubt?
Yes, I understand like how the process is going to be.
Okay, perfect. So now how to actually come up? Now it's just maths. See, if there is some value here and there is a big value here. Let's say it is 77 and we have a maybe 5 here. So we'll try to make all these values. First of all, like this 77 should be broken into parts of 5 first, and then there will be something remaining, and that will be here. But now the value that will be left here, let's say this was, instead of 77, this is 76. So we already know 70, instead of taking it 76, let's take it as 16. So 3 times 5, and then there will be a 1. But like I said, we'll try to have this as maximum. So instead of taking all of these as 5, 5, 5, and 1, what I can do, I can take 4, 4, 4. Right? Like 4, 4, 4, 4 is also 16, and the value on the right is maximum. I cannot have this more than 4. Is it making sense?
Yes.
Like instead of, I can also write this as like, what is the boundary condition because of this 5? The condition is all the elements on left of this should be less than or equals to 5. So this is also valid. 5, 5, 5, and this one. Like the value will be 16 only. So, and we are breaking the element into 4 parts only. So operations are 3 here also, and operations for this is also 3. But this is better. Why? Because the element is 4. All the elements on the left of this should be less than or equals to 4. All the elements on the left of this should be less than or equals to 1. So this is not optimal, this is optimal. Now, how to do this? Like what should be the value and how many times I need to break it? So it is very simple. If we have 16 and the previous one was 5, so just find first the seal of this. If you find the seal of this, you'll get how many number of times you need to break your this value, how many number of times you need to do operations, like how, not how many number of times, but you'll get how many partitions you need to make of this, so that the maximum value will be less than or equals to 5. Like how many partitions you need to make. So it is seal of this division, and the number of operations required will be -1. Why -1? Because see, if you perform operation once, you'll have two partitions. If you perform operation twice, you'll have 3 partitions. So by default, the number of operations is less than the number of partitions. So if this is the number of partitions that you'll have, this is the number of operations. Now, if this is the number of partitions, you can easily get this value as, if let's say this is x, so the value, this will be 16 divided by x, and this will be floor. Right? Why will this be? Because if you have 3 partitions, what is the value that will go in all of these and floored? Rest will be like getting bigger values, but this will at least get this much. Assume that you have a big, maybe a big pile of stones, and you have to make 4 piles. So 4 piles, each will have at least these many stones, and maybe there are some stones left which will go in these 3 piles. But at least these will go. So this is nothing but these number of stones divided by 4 and floor. So this is, what is this? X is the number of piles that you have to make. Is it clear?
Yes, clear.
You can do this using binary search also, but it is not required. It will like complicate the solution a little, and plus the time complexity will even worse. Like the time complexity will become worse, but it will also pass the test cases. Like time complexity will be n log n. This way it is O(n). So let me show you the implementation. So here first we have taken n as input, then we have taken array a as input. So this is just the previous element. Like starting from n, what was the next element? Like instead of previous, it should have been next. Like if we are at n-1, what was the next element? So if the previous element is already more, we'll update the previous and we'll simply continue. But if this should be next, like let me make it next only. Like if the next element was in case more than, or next element was less than ai, we need to break this ai into some partitions, like not partitions, but into some groups, right? So this is the number of groups that will break this ai into. So this is just seal of ai divided by next. And like I said, you'll have these many operations are required. If these are the total number of groups that will break ai into, this is the number of operations required to do so. And this is the minimum number of, like minimum value that will come into a group, the minimum value that,
The value of the segment
yes,
of each segment.
yes. like at least it will be this much. So this is now the next value for previous I. Is it clear?
Yes, it's clear.
Okay, what about others? Is it clear to?
Can you explain the X part again, X calculation?
Yes, yes. This is basically if, see, you want AI, you want to break this AI into some, like, let's say if this is 16 and the next value was 5. So you want to break, you want this AI to be less than or equals to 5, right? Like this element to be less than or equals to 5, right?
Yes.
So if you want this to be less than or equals to 5, let me show you here. See, if I had a 16 value and this is 5. So I want this 16 to be like 5, some pairs of 5, and then something remaining. So I just want to find how many, like if there is a pile having 16 stones and each pile should be less than or equals to 5, how many minimum number of piles are there should be. So it is 16 divided by 5 floor. Not floor, seal. Like this is the minimum number of piles that are required. 16, if each pile like can have at max 5 stones, how many piles are required if you have 16 stone? 4 piles, right? Is it clear now?
Yes.
Now, once you have this, like you need at least 4 piles. Now you can try to find if you have 16 stones and you have 4 piles, what is the, like if you give each pile say, like try to give each pile same number of stones, what is the number of stones that each pile will have at least? So 16 divided by 4 and seal of this. Like 4 was this thing. This is my x. And now this is my x. So this will give you the, at least there should be, like you can do this thing 4 4 4 4 4.
Okay. So you did both calculations on one step.
Yes, not directly on one step. These are like 2 steps only. But yes, the value that you calculated from here, this is the number of piles,
Oh, okay.
and then dividing this to get the next. Like how many stones will be there. This is just how many piles there will be, and in each pile, how many stones there will be.
Okay. So first one is seal and second one is uh you have taken the
Hmm.
AI divided by seal.
Like these are yes, these are the number of piles. This is the total number of stones. So each pile will have these many stones.
Each pile will have next.
Yes, and this is the total number of piles required. And if there are 5 piles, I need to do the operation 4 times. Is it clear now?
Yeah, clear now.
Okay. So it's clear to everyone, right?
Yeah.
Okay.
Yes, yes.
So now coming to this problem, we have Elena has a grid formed by n horizontal lines and m vertical lines. Now the horizontal lines are numbered by integers from 1 to n from top to bottom, and the vertical lines are numbered by integers from 1 to m from left to right. Now for each x, y, x is between 1 to n and y is between 1 to n. The notation xy denotes the point at the intersection of x, xth horizontal line, and yth vertical line. So 2 points x1, y1 and x2, y2 are adjacent if and only if x1 minus x2, like this is basically the definition at this point. Okay, I'll copy this. I'll explain the problem here. So adjacent point simply means that like this is adjacent to these points, these 4 points. This is just what it means by adjacent. So what we are given, like we have to go to adjacent cells, like from this cell I can go here, from here, here. Like this way, I have to finally reach this cell. Okay. So I have to reach this cell starting from this cell. And I have to, each time I can go to some adjacent cell. And the cells can repeat also. The only thing is that I have to color these, like these edges, the between two nodes, right? Let's say this is a node, so this is a edge. So I have to color these edges in such a manner that there is a path from this node to this node of length k, and the path is having like every two adjacent edges in the path. Like let's say this is the first edge, then I went to this, 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 and then finally this. So each of these should have alternating color. Like I can color the edges in either red color or white color. So R or white, R or W. So I have to color each of these edges in a way such that it's always possible for me to choose a path of size k, of length k, such that the path is having alternate edge colors. Is the problem statement clear? Yes, no. Or is there any doubt in the problem statement itself?
I'm not able to understand that color part.
Okay.
Like, what is the significance of using two different colors?
Like you just have to, like, let's say this is red, this is white color, this is red, this is white, this is red, this is white, this is red, this is white, this is red. So from here to here, see this path. So what is the length of this path? There exists a path of length 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 length, for which from this path to this path there exists a path of size 9, which is having alternate edge colors, right?
Okay, got it.
So if k was 9, you could have printed something like this. Like you could have colored the edges, like all the edges. I don't care about the remaining edges. So I can color all the edges like this. But if I print this, this will give me, this is one of the correct solutions. Like this is a correct solution. Why? Because this is the 9 length path, which is having alternate color edges. So we have to color the edges in this manner. Like we have to print any possible color. Like we have to color all these are also colored. So we have to color all of these. This was a valid solution. Is it clear now? For k0.
Yes, it's actually clear.
Now, first of all, let's try to find when does the solution doesn't exist. See, if I have to go from, if I have to go from the topmost cell to the bottommost, like the right bottommost cell, how many moves are at least required? N minus 1 plus m minus 1. Why n minus 1 plus m minus 1? Basically because this is the path. So n minus 1 because of these, and m minus 1 because of these. M is the number of columns, n is the number of rows. Is it making sense? So minimum number of moves required is this, right? I cannot reach from this cell to this cell in less than these moves, n minus 1 plus n minus 1, right? Yes, no?
Right.
Yes.
So if my k is less than, if my k is less than n minus 1 plus m minus 1, my answer is directly no, right?
Yes.
Yes.
Now there is one more thing. In this, what is n minus 1 plus m minus 1? What is n minus 1 plus m minus 1 for this problem?
7.
7. So in 7 moves, I'll end up on this cell. Now tell me, is it possible for me to end at this cell after 9 moves? Like forget about coloring.
It's possible.
Yes, possible.
It's possible because see, I'm here, I'll go back to this cell and I'll come back to this cell. So my point is, if you make one move and you want to come back, you'll have to do 2 moves. There is no possible way that you can end up at same cell after 8 moves. It's not possible. Is it? Like, no, is right?
Yes.
So basically the parity of these minimum moves should be equals to the parity of k, the path length required. If k modulo 2 is not equals to n plus m minus 2 modulo 2, basically this thing, minimum number of moves. If this is not equal, then the answer is no. Is it making sense?
Hmm.
Now we have one thing, like this is up till now, it's clear to everyone, right? Otherwise, I'll explain this again.
It's clear.
Okay. So now we have two things. First of all, k is more than or equals to n plus m minus 2, and k modulo 2 is equals to n plus m minus 2 modulo 2. So first of all, if this is, see, if k is actually like more than this, and two things are possible. When the difference between k is more, right? K minus, like these are the number of moves. The difference between this is divisible by 4, or it is not divisible by 4. Like anyway, it is going to be divisible by 2 because the parity is same. But if it is divisible by 4, what I'll do, see, one thing, first of all, one thing, what we'll always do is we'll color this thing. Like this path is always, like this is the final path that will lead me to, is it red RW or RB, first of all? I think it was RB, sorry. It is not RW, it is RB. Basically, like, but anyway. So this is the final path. Now, so this is the final path. Now I have some multiple of 4 steps. Like I needed 7 steps, but I am given 11. So I need to, you can think about this, like you need to make some multiple of 4, like you need to make some 4 moves. You should end up at the same cell, but the path that, like the edges that you'll follow should have different colors. So I'll take this thing. Like, okay, now see what happens. I'll start from here, go here, go here, go here. 4 steps. If I again want 4 extra steps, I'll again follow the same, again follow the same. So like this is always possible. And then once I'm done wasting or like completing my extra steps, I can follow this path. Right? Yes, no. Like forget
Yes.
about the color for every other vertex. I'm just saying if this is true, if like these 4 vertices, these 4 edges are in this manner, I can always circle around this and I'll get multiple of 4 steps, right? Yes, no.
Yes, multiple of 4 steps will be added.
Now there is one more thing. What if I needed multiple, like I was given that I want 12 steps, like I need 9 path of length 9 and I have 7 steps from here to here. Then I need extra 2, right? Now earlier when I was explaining you, I said I'll go here and I'll come back. But this is not true now. Why? Because the edge is having color red only. I cannot have this thing. So what I can do after this point, I can go up, then I can come here and I can come back down. So this will add 2, right? So color of this can be red, this can be white, this can be red, and all the other can be like randomly filled with any color. It doesn't matter, all of these won't have any effect on our answer. So these can be anything. The only thing is this path should have alternate color, this should have this color, and this should have this color. Then everything is possible. If the answer is like, if the answer is possible, this grid will always give you the answer. Is it making sense? Yes, no, why?
Yes.
Yes, clear.
So now it's just like constructive problem. How will you make this grid? So now it's very easy. You just have to, like, since the output format, you'll have to follow the output format. So follow one by one, go here, pick the color, give these. You have to like just look at here, like this is anyway, this you can initialize by like from like you don't have to do any computation here, but here you'll have to look like this like the colors in this part, the colors in this part depend on what is the color of this cell. If this is E, this should be R, this should be B, this should be R. In case this was R, this will be B, this will be R, and this will be B. And also this, if this is B, this should be R, if this is R, this should be B. So these four cells depend on this one, otherwise everything is fixed. Is it clear? And all of these don't actually, like you shouldn't care about these. Now you might think like, what if the grid size is very small and these and the like this cell and this cell, like these four cells are same? It won't actually ever happen because we are given that n is more than equals to 3 and m is also more than equals to 3. So if n and m both are more than 3, the smallest grid that you can get is of this thing. So this and this will always be different. Is it clear?
Yes,
Got
it's
it.
clear.
Is there any doubt?
The only doubt is how I will be implementing this.
Okay, now let me show you the implementation. So first of all, we take n, m, and k as input. Now, if n plus m, I haven't subtracted -2 here. Why? Because it won't change the parity. If n plus m modulo 2 is not equals to k modulo 2, or n plus m minus 2 is more than k, the answer is directly no. Otherwise, just take like this is your R string that you'll like, these are the row colors that you'll output. Everything is R only, and this is your columns that you'll paint. So these are n minus 1 strings, and every string is of size m and everything is R only. So this is the first, like first, how to show this. So this basically, this part is your coloring. What is 0, 0? So 0, 0 is coloring this and this. So this is red, this is red, and C00 is this cell, and C01 is this thing. So these two are white. Then this thing is from here to here, we are coloring these in alternate. So this will be W, this will be R. So these are, so we are going from 1, we are starting from here. C is 0, just give me a second. I think I made a mistake here. So C is R is of size N. So R is okay. R is this, like R is these, like the color for these. So if R is this is R, this is R, this is B, this is B. So this is this C0. C00 means this thing, and C01, that is 0th row, 0th column, and first column. These two are B. Now going in this column downwards, this will be R, this will be white. So this is done here, this thing. Now, once we have reached this point, we'll go in right direction and we'll color the last row alternatively. This will be R, this will be W, this will be R, this will be W, right? So this
Right.
is done here. Now this thing, this is the color, like we are checking the color of this cell. So this is n minus 1th row and m minus 2th column. So after checking this, if this is R, we'll decide the color of these three. This is the color of these three, otherwise the color is this. So I have already explained, if this is R, this will be W, this will be R, this will be W. So this is what we have done here, and vice versa here. Finally, we can print, yes, print row colors and column colors. Is it clear? So like it's just implementation, constructor. Is there any doubt in the implementation? Yes, no.
Yes, it's quite clear.
What about others?
It's clear, but we'll look at the code once and fully get it.
Okay, okay. Like if there is any doubt, you can ask me right now. But like if you have understood, if you like if you're confident that like you'll be able to implement this. Like if you are completely right now blank, like you're not understanding, then you can ask me right now. I'll explain it again.
No, I'm confident.
Okay. Like you understood how to solve, like how to approach this, right?
Yes.
Okay. So
Yes.
let's go to the next problem.
The only problem was to come with this kind of approach.
Yes, like knowing that the answer always exists, and how will you waste some steps, or how will you include some extra
Yes.
answer?
Yes, that modulus 2 and modulus 4 was very good.
So this is the next problem, and thus we are given that Kirill has two integers arrays a1, a2 till an, array A and array B. Now he defines the absolute beauty of array B as this thing, that is summation of absolute difference between AI and BI. So Kirill can perform the following operations at most once. That is, select two indices I and j and swap the values of bi and bj. So we have to find the maximum possible absolute beauty of the array B after performing at most one swap. So first of all, what we have to do, see we are given some, let's say this is array A, this is array B. So the, if let's say we are not performing any operation, what will be our answer? Our answer is summation of 1 to n ai minus bi, right? Now we can perform at max one operation and we'll shift these two. Let's say this is bi, this is bj, we'll swap these and maybe we'll get a better result, right? This is what we have to do. So first of all, the problem statement is clear, right? What we have, what we need, and we can do at max one operation, right?
Yes.
Now let's look at, let's say for a AI is this and BI is this. Like this basically means AI was bigger than BI. For some I, AI was bigger than BI. So what should be the J with which it's optimal to swap this BI with? We have two cases. AI was, let me write it here. So AI was this, BI was this for some. So like I'll try to draw this because it will be easier to imagine.
We should swap BI with some BJ that will be lesser than AI.
Like let me draw this. Like basically you have said the right thing, but let me draw this. Like when I
Okay,
draw,
okay.
you'll be better understanding this thing. Like this is some J. I'm trying to draw possible. This is AJ. This is BJ. This is BJ. This is AJ. Like these values. Like if this is 5, this is like instead of writing these values, I'm trying to draw some image. So this is 10, this is 7, this is, let's say 7, this is 4, right? So I won't be writing numbers, but you can get, like, understand, right? These are some relative numbers, like this is more, this is less. So let's take this one by one. See, if I swap these, earlier I was getting this much and this much, like this was a difference, right? This was getting added to my answer, right? If I swap these, I'll get, first of all, I'll get this much and then I'll get this much, right? Added, right? Yes, no?
Yes. Can you explain it again?
Okay,
And repeat it again.
see, earlier when I didn't had any operation, let's say these are two AIs and AI, BI, and AJ, BJ, 2 positions. So at this position, my AI was this, BI was this. So the absolute difference is this much, right? This is 7, this is, let's say, 3. So 4. I was getting 4 added to my answer. This is 10, this is 8. So I was getting 2 added to my answer, right? Yes, no?
Yes. Yes. Yes.
Now,
Yes.
if I swap BI and BJ, first of all, this is the difference that will get added to my answer because of this pair, right?
Yes.
8 minus 7 basically, and 10 minus whatever the number here was, right?
Mm-hmm.
So if you look at currently, okay, let me draw the previous one with, okay, previous one is with red. So let me draw the new differences with some other color. So I'll get this and this. So now if we look at this, see, let's look at this. Earlier also we were getting this part, now also we'll get this part. So this hasn't changed. We were getting this much, right? Earlier also we were getting this part, now also we're getting this part, basically this, right?
Yes.
See this part, this part. This part we were not getting earlier, but now we are getting this blue, 2 blue lines, right? Going in this part. So this difference was not earlier existing, now it is existing, right?
Yes.
So twice of, what is this? Twice of difference between BJ and AI, right?
Yes.
Okay, perfect. So now I'll do the same thing. AI is this, BI is this, AJ is here, BJ is here. Now, if we swap this, earlier we were getting this much. Now, if I swap these two and these two, again, what is the extra that we're getting? Again, the middle part, right? This
Yes.
part.
Middle part. Yes.
Now, some other combination. AI is this, BI is this. You can come up with it. Now, instead of doing this, let's say my AI is here and my BI is here. Now, AJ and BJ are here. Now, this is not optimal. Why? If I swap this, earlier I was getting this much. Let me draw this in a bigger way. So AI is this, BJ is this, AJ is this, and probably BJ is this. So earlier I was getting these. After this, I'll get only this much and this much. So it is indeed less only. Why? Because I was already getting this much, like, and I was already getting this much. But this part has now deducted. This part is now I'm not getting, right?
Yes.
And similarly, the other way around, if I do something like if AI BJ was here and BJ was AI BI was here and BJ was in between and AI was here, again, this is not optimal, BJ, AJ. This is not optimal because the part that is in between, I won't get it. I'll only get
The edge, the two extreme.
no, just okay, no. I have like it won't have any difference. It won't increase, it won't decrease. I have like look clearly, like see closely. If this was it, earlier I was getting this thing. Now let me draw it with other color. Now I'll get AI with AJ. So I will get this much and I'll also get this much. So this part is now also getting twice, right? The middle part. But other than this part is coming once and this part is coming once, right? This BJ you need to connect with AI, not AI,
There are two BJs.
this thing, right? So in this, it won't make any difference, right?
Yes. Yes.
See, AI is here, BI is here. What should I keep in between? Let's say AJ is in between, BJ is here. So basically AJ is in between AI and BI. So earlier I was getting this much. This part was coming twice. And now I'm getting this much and this much. Okay, so in this, it's decreased, right? In this, when AJ is in between, then the value actually decreased. But when BJ is in between, I think there won't be any difference. If I have AI, BI, BJ, and AJ, now it won't make any difference. So now after this, I will get first of all this much and this much. So this is exactly same as what I was getting earlier. Like the middle part, I'm getting twice. This was up till here, right? And other than this part is coming once. So earlier also it was same only, right?
Yes.
In this case, it got worse. So if you look at these four cases, the point is, if I'm selecting any AI, BI, I should select AJ, BJ such that it is more than this, right? Both of these AJ and BJ should be more than AI, right?
Yep.
So now it's very simple. Let's choose I such that AI is as small as possible. And let's choose J such that minimum of AJ and BJ is maximum. This is as big as possible, maximum as max as possible. So because this value will be as big as possible, this value will be as small as possible, and we'll do add this thing twice in our answer. Is it making sense? Like choose
Yep.
this as small as possible, try to choose this as big as possible, and just add this twice in your answer. Is it clear?
Yes, it's clear.
And like we can do, like, probably we don't have to do, but we can do this one more time, like other way around. Like instead of taking AI BI in this orientation, take this thing, right? We are missing this orientation, right? For
Yes,
this
we were
orientation, I
missing
have fixed this thing. So again, 4 cases you will draw, and this time let's fix this thing. So again, BI, AI keep here, and otherwise AI, BI. So you will see the same thing, that this part is coming twice. Let me draw it quickly. So earlier you were getting this thing. If you swap this AJ, BJ, if you swap these two i's, you will get, first of all, you'll get this much and you'll get this much. So you'll see that this part is coming twice, which was not getting you earlier. Like this was only coming earlier, right? This much, right? Yes,
Yep.
no.
Yes,
So
yes.
earlier we solved for all AI BIs. When AI was more than BI, we chose the such I such that AI is small as possible. And for that AI, we chose some J such that BJ, AJ, the minimum of these was as big as possible. Now we'll do the same thing. We'll choose BI such out of all such AIs for which BI is more than AI. We'll choose the maximum possible AI, and for this we will choose some J for which we have the minimum value of maximum
AJBJ.
AGBJ. And again, we will take the difference of those and add twice of that to our answer, like the maximum of these. So let me show you the implementation. See, first of all, we are taking array A as input, then we are taking array B as input. Then, first of all, if we don't do any operation, this is our answer, right? Absolute difference
Okay.
between A minus B. Now, considering from all of the i's for which AI is more than or equals to BI, I'm trying to find the lowest such value of AI. Basically, finding out of all of these orientations, finding an I for which this AI is as less as possible. So for those, once I have found that, now I'll again iterate now for all my possible values of J for which AI is also more than low and BI is also more than low. So these are my potential values of J. Basically these things. Both of these are more than my lowest AI.
Can you explain that low part again?
This thing,
Yeah, like what was the variable? What is the variable low?
low is the minimum possible value of AI out of all, like for all pairs for which AI is more than BI.
Okay.
Out of all of these orientation, I'm not looking at those orientation, BI, AI, in which BI is more. I'm only looking at these orientation, because
Okay, got it,
for
got
these
it.
orientation, we have found these 4 cases, and out of these 4 cases, we looked at these cases in which it's always optimal to choose such that if AI, AJ, BJ are more than AI, so I'm trying to find the minimum AI, this minimum. So that
I
will
got
be
it, got it.
okay. So once I have that minimum, I'm trying to iterate again. And then if in case AI is more than low, BI is more than low, my extra, this is my extra is maximum of extra comma 2 times minimum of these two. Why minimum of these two? Because we have already seen, like, it doesn't matter which one is above. It only matters which one was down. So whichever is down, the difference is between these two twice. This thing, the difference is these two twice.
Yes.
So this is that thing only, twice the difference between this. Now looking at the opposite orientation, that is when BI is more than AI. So basically BI is more than AI. So for that also we have done the same thing. Now if BI is more than I, try to find the lowest BI
Possible BI.
and then do the same thing.
Yeah,
And
got it.
now finally your answer is nothing but answer when you had no operations done plus extra. Is it clear?
Yes, it's clear.
Okay, so that's it, and thanks for joining. Bye bye.
Thank you, sir.